my name is Tasneem.
My name is Anila.
And today we are going to make elephant toothpaste.
Yeah, this is the biggest toothpaste I could find.
Do you even know what we're doing?
No.
A catalyst is any substance that helps to facilitate and accelerate a chemical reaction, but is not consumed in the process. The catalyst into this experiment is an enzyme called catalase, which is produced by the yeast, which is one of the ingredients we will be using. That will also go along with a bottle of hydrogen peroxide. The higher the percentage, the better. Dish soap and some dry yeast. Also food coloring, but that's optional. And a bottle for your experiment to take place. And a pan to capture the reaction product.
Act 2 is very important to remember when performing labs in chemistry since it covers safety equipment and types of fires. For this, we recommend gloves, goggles, an apron or lab coat to protect from spills and splashes. Also keep in mind this reaction is exothermic, so it does produce a little bit of heat. So those who are younger children, please get parent supervision. An exothermic reaction is a chemical reaction that releases energy by light or heat, which can be seen in Act number 5.
So the first step in our experiment is to dissolve the yeast in warm water, which can be an example of Act 1. As the yeast sits in the water, it begins to dissolve and the yeast is activated. Add 1 tablespoon of yeast in a mixing bowl and 3 tablespoons of warm water and mix until it is dissolved.
As that is dissolving, add your bottle or beaker into the pan and add 1/2 cup of hydrogen peroxide, which is a weak acid and has a pH level about 3.5. This can be more explained by Act number 3, which included the chemical names and formulas. And then proceed to add a few drops of food coloring and a squirt of dish soap, then use a spoon to mix. Lastly, add the activated yeast into the colored hydrogen peroxide solution and see how it expands into a big blob of toothpaste.
Let's look at this experiment a bit closer. A hydrogen peroxide molecule looks like this. It also contains a lot of water molecules, so like said earlier, the higher concentration listed on the bottle, the more hydrogen peroxide molecules there are, and few water ones. Hydrogen peroxide is a relatively unstable compound, and it breaks down on its own into water and oxygen, giving a little bit of time. The equation of the balanced decomposition of this reaction looks like this, and as mentioned earlier, a catalyst is any substance that helps to facilitate and accelerate a chemical reaction, but it is not consumed in the process. The catalyst was the yeast, which produced an enzyme which acted as a catalyst in our reaction. So when we mix the yeast in our hydrogen peroxide, The catalyst from our yeast rapidly breaks one of the oxygen atoms off of each hydrogen peroxide molecule, which leaves us with one oxygen atom in a water molecule for each hydrogen peroxide molecule. However, oxygen atoms don't like being alone, so they attach to one another, creating O2 gas, which flows out of our solution when the bonds of a molecule are broken, and in this fashion, the energy is released in the form of heat.
Normally, the slow breakdown of hydrogen peroxide into water-oxygen gas doesn't create a noticeable change in temperature, but because we used a catalyst to increase the rate at which hydrogen peroxide breaks down, increasing the rate at which energy is released, which causes a dramatic increase in our solution's temperature, making it exothermic. The large numbers of escaping oxygen bubbles that are produced from the catalyzed breakdown of hydrogen peroxide becomes trapped in the dish soap, producing large amounts of hot foam, also known as elephant toothpaste, which is an indication of a chemical change. One way that we know this is a chemical reaction is because many bubbles formed. These bubbles indicate that the hydrogen peroxide has been broken apart into water and oxygen. Once again, this is backed up by Act Number 1, which included the topic of chemical and physical changes. Thank you for watching, and next time we definitely need to find a bigger toothbrush.
The colors are cool, huh?
I think it's because the water bottle was bigger this time.
It was the same size. No, it was the same size.
The first time you did it, and